In this lecture, I'm going to be talking about what a career in corrosion might look like. The talk is based on one that was originally given by Drew Hevel, who is manager of corrosion control for the Kinder Morgan Company in Houston, Texas, USA, and is used here with his permission. Actually, it's not a career in corrosion. We don't really want to corrode things. It's a career in corrosion control. We're not pro-corrosion, we're anti-corrosion. Fighting corrosion is difficult. You have the laws of thermodynamics against you. However, everyone knows that superheroes can clearly avoid thermodynamics, and although we can't do that, we can come pretty close. So, in a way, we're a bit like superheroes. So what is corrosion? Corrosion is the deterioration of a substance, usually a metal, or its properties, because of a reaction with the environment. Metals occur naturally in their lowest energy state, for example iron ore. Converting such ores into material with desirable properties requires the input of a lot of energy. Corrosion, on the other hand, is just the natural process of returning the refined product to its lowest energy state. So in the previous slide, we take iron oxide, shove it through the blast furnace, turn it into steel, run it through a pipe mill and create a steel pipe. Then we bury it in the ground. Once we bury it in the ground tries its best to return it back to iron oxide again. Adding energy to iron ore to make it into steel is similar to rolling a ball up a hill. You're inputting energy and increasing its energy state. In this case, increasing its potential energy. However, left to its own, the ball will always try and roll back down the hill so as minimize this gravitational potential energy. That's why you don't see balls rolling up hills on their own very often. So, corrosion is a process of returning a metal to its lower energy state, or the ball rolling down the hill. On the other hand, corrosion control requires energy to stop or slow the ball from rolling down the hill. In Greek mythology, Sisyphus was the king of the city of Corinth. He was a famous trickster and was punished for believing he was more clever than Zeus himself. His punishment was to be doomed to roll an immense boulder up a hill, only to watch it roll back down, and to repeat this action forever. A life of futility and hard labour. So, a good metaphor for corrosion control is the worst possible punishment that Zeus, the most powerful god in Greek mythology, could give someone who thought he was clever. Another colloquially never-ending task was the painting of the fourth rail bridge. Once the painters got to one end, allegedly they went back to the beginning and started again. Actually, although a permanent painting crew was indeed employed on the bridge, they always focused on the most important and most corroded bits, as you would have hoped. More recently, the bridge was coated with a new paint system that should reduce the cost of maintenance and last for at least 20 years. So, why is corrosion control important? In a word, money. The cost of corrosion study funded by the US Congress was initiated by the US Corrosion Society, NACE, and completed in 2002. Corrosion costs and preventative strategies in the United States, the estimated annual cost at the time of around $250 billion. This amounted to around 3% of the total US gross domestic product. And similar figures have also been estimated for other major industrialized economies. Metallic corrosion impacts nearly every industry sector. For example, bridges, gas, transportation pipelines, waterways and ports, airports, railroads, electrical communications, utilities, vehicles, ships, etc., etc. So why else is corrosion control important? Public safety. In 1974, in the UK, a fractured pipe at a chemical plant in Flixborough released a cloud of flammable vapour that exploded with a force equivalent to 15 tons of TNT, the largest single explosion ever in the UK. 26 people lost their lives, 36 were injured, and 2,000 properties were damaged. Although there were many complex causes to this disaster, corrosion was implicated at an early stage. In 2006, a quarter-inch, approximately 7mm leak in a 36-inch, 1-metre diameter pipeline at Prudhoe Bay in Alaska spilled around 5,000 barrels of oil, which is around 800,000 litres, over 2 acres, 8,000 square metres of land. The failure was caused by poor maintenance and inspection of the pipeline, which in the end had to be replaced. So, important stuff, but what does a career in corrosion control look like? Is this a typical corrosion engineer? These are some of the pros and cons of working in the industry. You can have all the freebies you might ever want, but you're doomed to a life of futility and hard labour. You're not expected to spend a great deal of money in clothes, but neither are your colleagues going to win any Best Dressed awards. Your goals are to fight the good fight, protect people, property and the environment. But the laws of thermodynamics always win. These goals are for the good of society in the long run, but in the long run, none of us are here. There are many possible roles for corrosion control in almost every industry you can think of. Aerospace, plastics, pulp and paper, refining, R&D, consulting, academia, government, mining and water extraction, water distribution, etc., etc. There are a few different career progression pathways, whether you are in the technical role or in the business management role. If you're in a technical role, typically you'll be a single contributor as an expert. You would continue to develop your technical skills and experience throughout your career, and your degrees, certifications, licenses and other credentials will be very important. On the other hand, if you're in the business role, your main role will be to manage people and/or projects, and the importance of specific technical skills would decrease throughout your career, although you would still need to have an awareness of corrosion. Credentials specifically relating to corrosion may not be required, and you might be working in networking, marketing, sales, recruitment, etc., etc. So why would you consider a career in corrosion control? Seriously, after all of this, why would you want to do that? Well, the answer is again, money. Every year, Materials Performance magazine conducts its annual Corrosion Career and Salary Survey of NACE International members in the United States, Canada and Europe. The blue line in this graph is the average US annual salary for corrosion professionals. The green line is the 2004 average salary adjusted for inflation, so you can see that corrosion professionals' salaries are beating inflation. The red line is the average US salary. Typically, you would earn more than twice annual average salaries. As you would expect, the average salary in the industry increases with experience in the field, and after 30 years you might expect to earn roughly twice what you would if you were entering the profession. Again, as your educational attainment level increases from high school to postdoctorate, you'd expect to roughly double the salary you might get. One of the reasons we do so well is that there aren't many of us. We are a rare breed. But since there will always be corrosion, we will always be in demand. And this is a win-win for a stable, rewarding and well-compensated career. There are many opportunities for education in corrosion. The longest established graduate degree programme is at the University of Manchester in the UK, although other programmes are available. Professional training can also be undertaken by national corrosion societies, particularly the Institute of Corrosion in the UK, and by NACE International.